Hi everyone. Well, I would like to talk about compound inequalities and how to work them. Now, we've worked with individual inequalities, but now we're going to work with two at a time, and we're going to separate them with an and or an or. Now, an and represents intersection and or represents union. But let's review a little bit about union and intersection before we attempt these types of problems here. So here we have two sets, set A and set B. A is the set 1, 2, 3, 4, and set B is the set 3, 4, 5, 6, and they're represented in their respective circles. Now, if you're taking the union, you're getting all the elements together into one set, and that's what we have here. Now, how about intersection? Notice that both sets have a 3 and a 4 in common. So if we bring those circles together, there'll be an overlapping, and it'll be at that point, at the 3 and the 4. And so our set, A intersect B, is the set 3, 4. Okay, now let's look at our first compound inequality. The way you do this is you work each individual one and put their solution sets together. Now, an or is a union. So on the left inequality here, we're dividing by 2, and then we get x is less than 3. Now let's go to the right-hand inequality, and what we're going to do is add 4 to both sides, and we get x is greater than 5. Now we're going to pool them together here and say the set of all x's such that x is less than 3 or x is greater than 5. We want both solution sets because it's a union. This one here is an intersection. Again, we're going to work each one individually. So in the left-hand inequality, we're adding 3 to both sides, and we'll get y is less than or equal to 4. On the right-hand inequality, we're going to divide 2 into both sides, and we'll get y is greater than or equal to -2. Now, we can put them together like this, the set of all y's such that y is between -2 and 4, and then including -2 and 4. Now, here is another way of showing a compound inequality. This is the same as having two inequalities. 4x minus 3 is greater than 5, and 4x minus 3 is less than 21. So, but in this case, what we're going to do is add 3 to each section, and you have to be sure to add 3 to each section, and then we work that down, and then we're going to divide 4 through on each section there, and we'll end up with x in the middle. And so we get a set of all x's such that x is between 2 and 6. Okay? Now, let's do an application problem. Here is Gilbert, and he's in school, and he's studying science. Now, he's already taken some tests. On the first test, he has gotten a 56. On the second test, he's got 91. The third test, an 83, and the fourth test, a 62. Now, to get a C, you have to get in the range of 70 to 79. Now, what if he took another test? How could he get an average test score that would fall in that range 70 to 79? So we can set up a compound inequality here. An average is you take all the scores and divide by the total number of scores. And so that's our middle section of our compound inequality. And we're going to work that down. So first thing we can do is we can go ahead and multiply each section by 5 to try and simplify it a little bit. Now we're looking for an x such that when we take the average will fall in the 70 to 79 range. So we're working this down. We subtract 292 from both sides, and we're going to land up with x is between 58 and 103. We have to get a score in that range to get an average that's in the range of 70 to 79.